All right, we'll look at a couple of examples of substituting into formulas and transposing the formula. With the first example over here, example 1, I will substitute first and evaluate it. And for the second example, we'll do the other way around. We'll transpose first and then substitute and evaluate. Okay, so in this question, the formula for interest, simple interest, is PRT over 100. You are given the amount of the principal that Daniel invests, $4,000 at 6% per annum, and he earns $720 in interest. For how long was this investment? So you have to evaluate our time. Okay, that's what we don't know. So these are the givens that I have rewritten. If we now substitute that into the formula, we get 720 is equal to 4,000 times by 6 multiplied by time divided by 100. What I'm going to do is I'll evaluate all the numerical values separately, which gives me 4,000 times 6 divided by 100 gives me 240 times by time. That's equal to 720. To get rid of the 240, we do the opposite of multiplying, which is divide by 240 on both sides, and we end up with time is equal to 720 divided by 240. And if we evaluate this, this gives me 3. So 3 years, as we know in the formula, the time is given in years. So that's 3 years. For the second one, you are given the formula to calculate the current, and the current is given by 240 divided by R. So let me write that down. So that is given by 240 over R. Okay, we've got two parts to this question. Now, one, transpose the formula to make R the subject. Okay, so we want to make where I is right now, that's where R should be. Okay, now there's a couple of ways of doing that. We know that if we have our unknown in the denominator and only one variable on the other side, the simplest way to do that is just to swap. So that gives me R is equal to 240 over I. Okay, now how this is done, and that's the long method. So I could going to do the second method, which is I equals 240 over R. So because our R is in the denominator, okay, to get rid of that, we multiply by R on both sides, and we end up getting IR is equal to 240. Now, because we have to make R the subject, so we don't want the I and R are multiplied by each other. To get rid of the I, we do the opposite, which is divide by I, and that gives me R is equal to 240 divided by I, which, if we have a look, it's the same thing. Okay, then part B. Part B is asking us to, if a kettle has a current of 1.2 amperes running through it, find the resistance of the kettle. So because we have to find the resistance of the kettle, all we do is we just take the resistance formula, which is R is equal to 240 divided by I. Now, you could go with the original formula and substitute as well, okay? But since the resistance formula is already there, all we do is just take that and substitute our values. So we are given an I value of 1.2 amps. All right, so let's substitute that. So that will give me 240 divided by 1.2 amps, which gives me a value of R equals 200. And because it's in ohms, we can just write down